The following content has been provided by RWTH Aachen University.
Welcome everybody to Designing Interactive Systems 1 today. So today we'll start the next phase and the final phase of this class. And maybe the one where you'll learn the most sort of new process techniques, not just knowledge about how human psychology works, but actually ways to design the process of creating a user interface. So before we do that, we'll jump into a quick review. I hope you've all recovered from the midterm. So this should be super easy because you've all learned this stuff anyway. So the phases of the technology life cycle. What were those again? Yeah, go ahead.
First of all, we had the enthusiast phase. That was where everything was complicated. And
Enthusiast, right?
Yeah, and then we had the professional.
Professional.
It became less complicated, but still needed training. And then there was the consumer phase.
Consumer, right?
Like in everyday life. And I don't know if you count this, but then there was like a sweet spot of like simplicity and functionality.
Yep.
And then we also added Baroque phase, which
Right.
is when technology took on a lot of like extra
Right.
functionalities.
Right. Through the sweet spot to the Baroque phase. That's right. So not all technologies will roll out exactly like this. Sometimes, for example, you have a technology that starts out as a consumer technology directly, but this is something we see fairly often when new technology enters the market, so to say. Next up, we had 3 vision videos. So put that there. What was the key new thing and put that there? Yeah?
Gesture recognition and multimodality, combination with the pointing system.
Exactly. So and with voice, right? So voice recognition plus the gestures in combination was the key idea there. Yeah.
The system had history memory.
Right. It was actually understanding it was remembering parts of the past conversation. That's right. Yeah. Apple Knowledge Navigator. What was new there? The biggest news, so to say, or the key assumptions?
The agent that was displayed there made people more familiar with the idea of an agent.
Right. It really brought agents to the forefront of people's minds, right? And of course, the whole multimedia wave was also being reflected by being able to pull in simulations and video conferencing and all those kinds of things. And yeah, that agent understood a lot of stuff, right? So that's we're still waiting for that to fully become reality. And then we had Starfire. So what were some of the key new things or different visions of the future there? What's most unique about Starfire? It's like if you need to share, yeah.
Facing error was also implemented, like interaction techniques when facing error.
Yes, that's actually, that's true. And I would actually say probably that's not a new vision of how to do computing, but it was more like about the process, right? So it was more like, oh, if we do create a video prototype, and that would have been my next thing, if we do create a video prototype, then we need to also make sure that we show how the system deals with mistakes that people make. Because as you know from the first part of this class, people make mistakes, right? That's how we work, right? That's perfectly natural. Right, but so Starfire also brought some sort of non-standard technologies, right, to the office. What were those? Yeah, right.
Like a vended screen.
Right, so this bizarre bent workstation, right? Was the most noticeable new thing that people say when they talk about Starfire. They're like, it's this like weird bent workspace. And then of course there were other things you saw, like remote control of cameras and multi-party video conferencing with lots of interactions being possible, like signing a document just by pointing and stuff like this. Okay, so a lot of things in those 3 vision videos, and we reflected a bit on like in how far have these become reality, or in how far have we done something different, how has technology evolved differently, or in how far are we still sometimes waiting for that vision to fully become reality, right? It's not everything devolved in the way that these visions, of course, foresaw. And then we looked at ubiquitous computing as sort of the final, so to say, grand vision of the future. We did talk briefly about like the World Wide Web, of course, and about virtual reality. But Ubicomp was sort of the last one that we looked at. So what were these device classes in Ubicomp that we distinguished? Yeah?
We have the tabs, pads, and boards, and the tabs were like really small, and
Mm-hmm.
the pads were like tablets,
Mm-hmm.
and the boards were just boards.
Right. So pads, tabs, pads, and boards with those typical device class, device sizes. And some of these sizes are not something that you would necessarily derive from technical considerations, but really just from how people work and what kind of objects we typically handle, right? So that's why these device classes sort of emerged. All right, and we already talked about one of these things, as you mentioned, like, put mistakes into the video prototype when you make a video prototype of a system, as opposed to building, a functional prototype where you're, like, basically when you build a functional prototype, it works the way that it works, and if you want to change that, you need to literally, reprogram, right, and change your code and stuff. But if you have a video, then it's very easy to just make this thing do one thing in one scene and then do something completely different in the next scene, right? Maybe one scene that perfectly understands everything that somebody's saying, and then the next scene, then it ignores the conversation that's going on, right? So you have to somehow explain why these 2 modes would be happening with the same system. And so one of the things was putting mistakes in there. Any other things that that you remember from the lessons learned from Starfire, from the video prototyping? Apart from that, yeah.
About the prototyping itself.
Yeah.
Because of their budget, they just ignore some technologies to be implemented in the video.
Mm-hmm.
Like they used angles,
Mm-hmm.
camera angles.
Mm-hmm.
To just reduce some implementation.
Absolutely, right? A video prototype also has implementation cost of making it work in front of the camera, and some techniques can be shown different ways, and showing it one way, like looking at the user's face, is much cheaper than having to actually synchronize, a drawing or something on the screen with the user's finger movement on the surface of that screen. Exactly. Okay, so let's wrap that up, and let's look at where we are right now, okay? You may remember this from the first day of classes. I explained to you that these are the 3 big pillars of what we're going through in this class, right? Learning about human psychology, understanding how people work and think in general, right? And if you look back at this, you'll notice that these don't really depend on the use case or the context of work or the task that people are doing, right? These are kind of universal truths about human perceptual, cognitive, processes, including the things about visual design that you saw, like, the park or CRAP principles, and in general, all these rules you can basically apply anytime somebody shows you a UI. You can take out checklists if you want, and go through it and say, yeah, that's probably not good. You should probably change that. And you'll be rarely wrong. But this left part, only really addresses, I don't know, 30% of the problems that you may encounter with the user interface, or maybe even just 20. And it's really good to apply this thing, and it's really helpful to know these rules when you design a user interface from scratch, absolutely. But for most questions that you may have on how to design a UI, or whether it's a good UI or bad UI, I can't give you the answer, and you won't be able to give the answer either. Why? Because in order to answer that, you actually need to know what concrete environment this is taking place in. What's the task that people are supposed to do? What is their background knowledge? Are they experts? Are they just starting out? Is it for casual use once in 3 months, like a ticket machine or something? Or like a flight booking system for tourists, right? You use that, like once a year or twice a year? Or is it for something that somebody is using 8 hours a day? And there are so many other factors that go into this, like what is people's work environment? Are they using this mobile or stationary? So there's lots and lots of questions. And what is their background? What have they learned in order to use this system? Can you assume training on the system? So all these things, you can't just give an answer saying like, that's the better design, or this is the better design, like we can with some of these early models here that we saw, right? We can say, well, law of whatever, proximity says this is the better layout of these buttons than this other one. For lots of questions, this won't work because you need to know what the user knows, what the task is, what context they're working in. And so for this, the only thing I can give you is a process to find the answer. I can't give you the answers, but I can give you a process to find the answers. That's what we're going to do in this third part of this class, right? And in between, we had these case studies where I said this is a little bit like an architecture class where we look back at sort of how did our field get to where we are now, so that we better understand when somebody comes around and says, ooh, in 5 years, everybody will be using AR goggles and nothing else. You can say, like, well, we've seen visions like that, and so let's play this out. Let's see what that means, how that reflects on basic needs that people have. For example, if everybody is only using AR goggles, are we not using our hands and fingers to touch anything anymore? Are we just waving our hands in midair because there's no device, to touch? Does that make sense? Is that always good? I don't know. But knowing this history helps you to also judge what's happening next. So we've covered the roadmap. On the roadmap, we've covered the human, we've covered the case studies, and we'll now enter this third part, the development process. So remember this. When somebody asks you, so what do you know about HCI? You can say, well, yeah, on the one hand, I can give you answers without looking at the context and the task and the user profile. I can just tell you, that's not a good idea, or this is a better idea. Right? When anybody breaks fundamental principles like visibility, affordances, natural mappings, all these kinds of things, constraints, or doesn't reflect or doesn't properly deal with errors that people that we've talked about, or breaks the visual design principles or uses them wrongly, you can say, not a good idea, fix this, right? I can tell you this. But in many cases, the HCI knowledge that you will have, and probably the more important one, is this, right? Because this will give you a feel for how do I walk the path of finding out together with users, and not just users actually, all the stakeholders that are being touched by a system that you're introducing. How do I work out what actually will be the best solution for this system? And we're doing this at the lab. We're consulting for external clients and also internally in the university. And we find that this is much, much harder. It's really easy to take an interface design and go through and look for some basic, are the basic principles of psychology being, worked with or worked against in this interface. Right? That's not hard, and that's also not much debatable, right? You can just say, well, look, this is obviously not a natural mapping, so fix it. But here, you need to go in, you need to find out, first of all, who is being touched by a certain system, and who is being influenced, or whose work is going to be changed by a system. The other day, we redesigned a form that maybe at some point you will see for submitting, when you were ill after an exam and you have to hand in your sort of your doctor's certificate. So we were redesigning this. And when we came in, the design, there was already a design, and it was okay for students, but we discovered that another group of people who were really being influenced by how the system works was, of course, the ZPA, the Central Administration Office that takes care of examinations, right? And they were like, oh my God, this is a terrible process to do it. It was supposed to be all digital, of course. This is a terrible process. This is not going to work for us. And so we went back to the drawing board, found out how it works better for everybody involved, and laid it all out. And ultimately, we came up with a solution that was great for students, requires much less entering data that is unnecessary to enter really because the university already knows it, and also works great for the ZPA. So involving all the stakeholders in this process and managing these things is really hard. It's an uphill struggle. Because not everybody has been to DIS1 and knows these things, right? A lot of people are not aware of this kind of thinking. So you often need to go out and basically teach people the process along with what you're actually supposed to be doing. Right? I often find myself going in with clients and saying like, okay, so let's do a user study or something, and they're like, why would we do a user study? So then I go back, okay, let me tell you why this is important to do. So this is what we're going to be doing in this third part of the class. First of all, just to get this out of the way, you may still be aware of or have heard of the waterfall model, and it often, for small projects, is still something people pull out. And yeah, it's a way to break down your task, but it has an issue, right? It goes from analyzing the problem, then making a design, then implementing it, then testing it, and then shipping it, and then maintenance starts. And these things are typically in larger projects, marked with milestones that are in documentation and software. And this is, still widely used in software development, but it has major issues. The biggest issue is that these phases, of course, in practice, these phases don't fall apart that clearly, but more importantly, you often need to go back. And why? Well, as you go through a project, for example, let's take this example I was talking about with this little form for people getting sick during and not being able to attend an exam, so they need to hand in this form. As we talked to people who were involved in the project, we started to understand how they actually work and what they actually need. So this is happening in a phase where I can only talk to these people by showing them, for example, one possible solution for how the new system might work. And then they say, that's not going to work because you're totally ignoring the fact that I'm doing this and this and this and this in my work with this process. And then I'm like, oh, okay, so I've now learned something about how the process works. So as you go through this process, you are becoming smarter about what the problem actually is that you're trying to solve, right? And so as your understanding grows, of course, the solution, the best solution you can build also changes, right? When you go in, you're pretty naive. You don't know how, the people who are going to be using your software, how they actually do their daily work right now. You're not aware. So you need to learn this, and you need to talk to them, and you need to work with them and understand how they do their work now, so you can change what they're doing with a new software, a better digital support, for example, in order to actually get to a more productive solution. This is super current right now, right? You're probably aware of the what is it called? OZG, the online access law that says that all public bodies will have to provide online access to their services, like, the Citizens Registration Office, like Einwohnermeldeamt, like anybody, right? All the public bodies in Germany will need to offer online access to the services by what, like end of next year or something like that? End of this year, it's something very, very soon. Anyway, so this is happening everywhere right now. Everybody's digitizing their processes like heck, and if they make a mistake and just take a shot at it and do something, then they're usually making things worse rather than better. So this is an incredibly high demand right now, knowing how this works. The other problem that we're often facing is that when you when somebody just says, yeah, okay, so students need to hand in a doctor's certificate after they weren't able to attend an exam, right? So like, okay, so the student can just, take their exam and go online and fill out this form and hand it in, no problem, right? What you're ignoring is that, wait a minute, these students just, deregistered from an exam because they're sick. So they're probably in bed with a fever, right? So with like a head like the size of a balloon, and they're probably not at their best cognitively to deal with a complex form-filling interface. And so let's make sure that we make it super easy and convenient so that we don't, mess with these people more than we already need to. As soon as you become more concrete in your usage scenarios, you realize that, the actual situation isn't as ideal as you're imagining it to be. And the problem with this waterfall model is, if you have a wrong assumption, it's hard to find, first of all, because you'll only discover it when you test in this classic model, where you only really talk to your users with your design when you're done with everything. And when you're at this point, and you do find a problem with your design, boy, that's expensive, right? Because you're now re-implementing everything based on your changed understanding, on your grown insights that you now have. So not a good idea. And we know better. And we actually know better at least for like 40 years now. Because, even Kai as a conference, right, has been around for 40 years. The books about human-centered design and all stuff, the first stuff came out in the 80s, right? That's a long time. So you would normally say it takes about one generation to die off until bad habits, go away, but that hasn't happened, right? We're more than one generation into knowing how to design better software, and it's not happening yet in many cases. Somewhere it's happening, but we have a lot of people like you, except they're not taking a usability class, who enter the market every year from the universities, who are excellent programmers, excellent coders, excellent developers, but they don't have this understanding. So I don't see how things are going to significantly improve until you all go out and make sure these people understand how to do it right. So the better way to do this, and this has been known for a long time and is known under many names, I'll call it the DIA cycle. This cycle is called DIA cycle because it consists of 3 phases: design, implement, and analyze. I could also have called it design, implement, and evaluate, but then it would have been the DIE cycle, and that sounded a little bleak to me. So DIA it is. Analyze basically means, or let's say with the design, you come up with an idea for your interface, your proposed software, your app, whatever it is. And then in the implementation, you build some kind of artifact, some kind of prototype. Not the final system, mind you. Implementation doesn't mean sit down and write code. Implement can also mean draw something on a piece of paper. It's just making a prototype. And then you analyze whether you are on the right track. So you take that prototype and you take it typically to users and you test with them to see, hey, is this making sense? Am I on the right track? Would this interface work for your workflow? Would it actually make your life easier? Or are we just creating digital hell for you right now? Okay? And so then you get feedback, and with that feedback, you go back to the design phase. And you do this a bunch of times, right? This is important. So let's look at this DIA cycle in a little bit more detail. First of all, if you only go through it once, you basically just did the waterfall model, right? So usually you need 2 or many more iterations of this. It's not unusual that you would go through maybe like half a dozen prototyping stages and interactions with users, testing your idea with users, until you actually get to what you want to build for real. What happens in these iterations? Well, hopefully you're not starting at square one, because I already said, right, you learn as you go through these phases, right? As you go through the process, you start building an understanding of how users actually work and what their actual needs are. So with each of these iterations, what's happening is that your design will become more concrete and more precise, more details will be fleshed out in your interface, right? At the beginning, you're just sketching a bunch of screenshots basically with pencil and paper, or maybe you just literally like your first prototype could be just a story, just a paragraph of text that says, this is how I imagine my system to be useful to the user. And even that, like a paragraph of text describing a typical use of your system, could be something you can take to a user and say, does this story make sense to you? Is this how, could you imagine yourself using the system that way? And so, and as you go on, your interface becomes, your design of the interaction becomes more concrete, more precise. The other thing that should change is, that's why you could maybe imagine it more like spiraling in on your solution, is that with each of these cycles, the analysis that you're doing, the testing, the evaluation, and the feedback that you're getting from users should be focusing on smaller and smaller issues. In the very first steps, you might say, well, so we're planning to design this mobile app for you, and we have this user story or the screenshot prototype here, this paper prototype for you. And they're like, mobile app, what you're talking about? Our hands are full. We can't use a mobile device while we're doing our job, because maybe the work that you're doing requires them to have both hands, working a machine or something, right? And so the only solution that would make sense for them is something they could use with other senses, like, I don't know, voice, head-mounted AR glasses, whatnot, right? So this is like the big stuff that you want to get out of the way quickly, right? These are the big issues that you need to work out. And then as you go through these iterations, each time, and then you're like, okay, so we now know that we need to really work on an AR device for you guys, like head-mounted glasses, because the mobile app doesn't make sense. So then you get down to the details of the interface and what to put in the interface and how to arrange things, etc. And in the very last iterations, then you're doing what magically people out there seem to be thinking is all we're doing in interface design, which is like changing colors and positions and sizes of buttons on a screen, right? Yes, that's also part of interface design, but frankly, that's the easiest part, and that's the stuff that you can fix like days before the deadline. Not a big deal. The big stuff, the really scary mistakes, those need to be cleared out way earlier, and this is the hard things that you need to be doing. And then, in the end, you get to polishing and things like that. And so with each iteration, what's happening is that your prototype gets more detailed, and it also gets more technically complex. Like I already said, like an early prototype will probably be something on paper, right? Literally not involving a computer at all. Hand-drawn sketches on paper. And then maybe you're going to be creating a couple screenshots that kind of look like the interface, and maybe people can click through them. And then at the very end, you're starting to build something, or next maybe you're building something with an animation software that simulates the UI, or some other kind of technology. And then in the very end, you actually get to writing literal functions in code that actually implement this stuff for real. So the more complex your interface becomes and your prototype becomes, of course, the more expensive changes become, right? So it's easy to change a piece of paper, just toss it away and draw it again. It's done in a matter of seconds, right? But changing how a technically complex software prototype works is more expensive, and so we're trying to keep those costs down. So the overall thing is here: you want to fail fast, fail early, as they say, right? You want to find the big design bugs first, and you want to focus on the smaller ones later. Right? That's the idea behind this DIA cycle. So let's maybe try to make this a little bit more tangible, to unroll the DIA cycle, right? Let's imagine we have a couple of these iterations, and I'll throw a couple examples at you how this could work. So let's say you're at the start of a project up here, and you're doing your first design tasks. You might be brainstorming different representations, right? Maybe you're saying, oh, it could be a mobile app, it could be in a head-mounted device AR thing. It could be a website that people can access from anywhere they want, or whatnot, right? It could be a voice assistant kind of thing, whatnot. So you brainstorm these different representations, you choose one, and you rough out the interface, right? Very, very, very coarse on paper with pen. So the result of this design is then that you implement something that is a low fidelity paper prototype. And we'll talk about how paper prototyping works. There's actually a couple interesting tricks you can do to make that work. People write entire books about paper prototyping, so it's not a trivial task. So then, you've done that, and now you need to, of course, why are you making a paper prototype? Well, to test it, right? To see whether it's the right approach. A couple years ago, I learned a wonderful metaphor. Somebody said, a prototype is always a question. A prototype is always a question. What does that mean? The only reason to build a prototype is to use it to ask questions, right? To find out more about what you're ultimately building, right? You're not making it to fill some deadline or something, or to complete a milestone and then toss it away. No, you make it in order to take it, in this case, to users maybe, and test with them whether you're on the right track. So prototypes are questions, and you ask these questions then in some walkthroughs and redesigns that you do then in your analysis and design phases here, where you start fine-tuning your interface. Maybe then you get to designing individual screens at some point once you've settled on the general way that your system works, your app maybe. And then you can take also your design and go through and say, oh, I've got these 10, 20 interface guideline list, checklists that I have. Let me go through and see whether I'm breaking any major rules here, for example. Is this system actually using concepts and words and terms and principles from the user's work domain, or am I throwing technical jargon at them? I don't know whether you've seen this, but if you use RWTH Online and create a new class, there's something like what is it called? An equivalency node. And I mean, I'm a computer scientist. I can sort of kind of imagine what an equivalency node is, but can you imagine somebody from another field seeing the word equivalency node and think like, okay, I'm trying to model a class I'm teaching here with like a lecturer and a lab and students, and equivalency node is a word I've never heard in my life, right? So this doesn't belong in an interface that is about teaching, right? So for example, these kinds of things you discover then, and you discover them by checking against, for example, common rules of interface design. The results are medium fidelity prototypes. We'll talk about how these work, right? They will start involving computers, but not necessarily mean that you program code, but it could be, for example, designing an interface in PowerPoint, right? You can actually use PowerPoint to fake user interfaces pretty well, and it's much quicker than writing entire code bases. And there's a bunch of different approaches here. We'll talk about software prototyping tools later on. And then as this becomes more and more concrete in the final iterations of your DIA cycle, you will broaden your test base, right? You will maybe create a wider user base that you use as testers for your advanced prototypes. These prototypes then become higher fidelity, like they get more and more to the state where they almost look like the real thing, right? So at first glance, I could maybe mistake it for, oh, this basically is complete, right? It's a complete app. It's not really, it's only looking like it, but it's good enough to have a lot of people use them, test it with them, see where they fail, whether you made any mistakes, and then still change and optimize your design. And then finally, you get to field testing and alpha beta tests. This is when you typically, when you typically see companies letting stuff out of their labs and releasing a beta, right? So the moment you see a beta, it means that lots of people can join in and test this and give feedback. But by that point, if they're following a proper DIA cycle, they've already gone through lots of iterations before that, right? So here, hopefully, you're only looking for small changes or really rare cases where your system, has issues. And that takes you then ultimately where your implementation then is no longer a prototype, but actually, is the working system, right? That's actually implemented in the final production language of your choice, etc. So we're basically involving more and more users, like in terms of numbers, we're involving more larger and larger user test bases here towards the end to find like, rarer and harder to identify problems. But be aware that, for a lot of time of this process, you are not coding, right? You're not opening up, C# or Swift or Java files here. You're working with other tools. They may be digital tools, but they will typically not be coding development tools. And that's why you're learning some of the things here in this class that are a little different from what you're learning in the rest of your computer science classes. So you'll be doing projects, right? In this third part of the class, you will be working on a project. And in your projects, the DIA cycle will also be happening. Now, we don't have months available to do this. Well, we do have months, but a very small number of them. So, and there's Christmas in between. So we will have milestones for you to, for the brainstorming, storyboarding, prototyping, user observation, and testing stuff. And all these will be feeding back into your project design. So you will start out with an idea today, maybe even, and this will then, develop. It will be a naive idea, a first stab at a problem, and then over the course of time, you will get to more and more advanced understanding of the problem, and your interface will reflect that. In a real project, you would require even more iterations, right? If you were actually building a large-scale software project. You will also notice that we are actually, yeah, go ahead. Yeah.
Something on the last slide.
Yeah, sure.
So on the concept of fidelity, so what are the differences between those low
Yeah.
and high fidelity? So
Yeah.
Are they more related to the functionality aspect of things, or just the optical aesthetics, appearances, like UI stuff?
Yeah. Actually both. Because what this means, the fidelity in this case is and we'll talk about how some of these things flesh out, but you can have a prototype that is just a sketch on paper, right? So it looks rough, right? So low fidelity in the presentation, but also B, it doesn't actually have any implementation behind it, right? It literally is just a piece of paper. So also low fidelity in the implementation. And then you may have, for example, a screenshot prototype. And you can polish a screenshot prototype, of course, as much as you want, theoretically, so it would look like the final system. Then it would be very high fidelity from the presentation point of view, but it would still be very low fidelity or a little higher fidelity, but still fairly low in the terms of implementation, because you could, make maybe links in your PowerPoint file go to different screens, so I could maybe actually follow different paths through the UI, which is hard to do with a paper prototype. But the idea in general is that both of these fidelities actually kind of advance alongside with each other. So the reason for that is you want to optimize your time, right? You want to optimize the development time, because you guys are going to be expensive out there on the market, right? You're going to make a lot of money, and that money needs to be paid by somebody. She's like smiling, yeah, lots of money. No, but there will actually be, there will be a big pressure on making sure that you're working as effectively as possible, and plus your entire development team, right? Because developers in general are expensive resources. And it also doesn't make sense to waste development time. So what we're doing is, in the initial prototypes, we're making them low fidelity in their looks, and they're also going to be low fidelity in their functionality, right? So they're not going to be doing anything. They're going to be pieces of paper. And then in the medium fidelity, you make them look a little bit more like a real user interface, so that people can relate to them more as, that looks like an app. And they may also already have, a couple hyperlinks inside that let people jump through the system and simulate an interaction a little bit more realistically. And then as you move to your high fidelity prototypes, then you're actually maybe, for example, building the interface with actual components that look like the real user interface components, right? A lot of development environments let you quickly throw together a UI without it actually doing anything, right? So you can do that, and then maybe you only take, let's say, one path through the interface, and you implement that out so that people can take that path, but they can't take any other path. What do I mean? Well, maybe you show an interface with 5 drop-down menus with 20 options, but only one actually works, right? And you say to the user, okay, assume you want to create a new document, because none of the other functions actually work at that point, right? And so then they try that out and they give you feedback on that particular path. So yeah, thanks for the question. Presentation fidelity and implementation fidelity are actually two separate things, but we tend to advance them sort of in lockstep. That's kind of the idea. Right. So let's look at the at Norman's book, because you've been reading that, and there actually he also added something in the 2013 edition that wasn't in his original version that kind of reflects this. Right? And in his book, it's called the human-centered design process. It's essentially the same thing. It's the DIA cycle. Right? He also starts out with idea generation, and then he takes prototyping, and he says, and then there is the testing and observation. So he pulled the analysis phase basically out into two separate phases, but it's the same philosophy behind that. And what's actually behind both the DIA cycle and the human-centered design process is a deeper, a broader concept that's called design thinking. And you've probably heard design thinking as a term being thrown around. That is actually what we're trying to do here on a simple basis. Norman once said, like, one of my rules in consulting is simple: I never solve the problem that I'm asked to solve. And that's one of the things that you will learn as you go through this process, that oftentimes when a client comes to you and says, I need a system for X, what you'll find is actually that that's not really what they want, what they need, because their own understanding of the problem they have hasn't been probed enough yet, right? They don't really know, the entire team doesn't know yet what the actual problem is. And so it's often worth poking in and saying, like, okay, so maybe, I'm going to make something up here now. Maybe an office comes to you and says, we need a more efficient way to fill out these paper forms, right? And they say, we would like you to write software that drives a dot matrix printer to fill out these paper forms more effectively, because it's so slow to write them out by hand. And if you've used pink order forms from the university in your Heavy job, then you know what I'm talking about. So you might say, okay, we can do that, but is that really your root problem? And then maybe you would find, well, the actual problem is that this whole paper-based ordering process is not the most effective way to do it, so you actually want a digital order process instead. You don't want to fill out paper forms more effectively. That's just fixing things on a very superficial level. And yes, it would be an improvement, but the root cause, the underlying issue is something else. And so this root cause analysis is what this is called, is something that helps you discover problems. Because in the real world, I mean, you need to discover problems. Here at the university, you're often being given a problem. And you may think that's tough because, oh, another problem I need to solve. But that's actually easy because you were given the problem that you need to solve, right? And your whole engineering training, by the way, is mostly preparing you for solving problems. There's very little that helps you uncover what kind of problems you should actually be solving, because that is more of a design thinking. It's more how designers think. They actually know that they need to understand first what is the issue that we're even addressing here, right? So that's why we often rush in with our engineering mindset to solve a given problem without questioning whether it's even the right one to work on. So instead, what we're going to be doing in root cause analysis, and what you'll find will become sort of your modus operandi and your thinking pattern when you go through interface design and designing interactive applications, is that you try to step back and say, like, okay, yeah, I understand now what the issue is, but is that really, am I solving it at the right level here, right? And when you do find that you can solve things at a deeper level, at the root problem, you then look for the right solution to that problem in order to resolve this. And understand this needs to happen as early as possible, right? Or else you are starting to solve this superficial problem and you're going into, like, advanced prototypes and stuff. And at some point someone says, well, wait a minute, are we? That's actually not the issue that we really have. So that would be expensive, right? So let's do a little in-class exercise here. I'll give you maybe, before we start with this, one more example that helps you understand the process. Let's say that people are using a washing machine, and the washing machine manufacturer says, well, we find that people have a lot of issues turning the machine on before trying to select programs. So we want you to redesign the interface so that the power on button is more noticeable and is easier to find. And then you, like with your Charlotte mind, you go in like, wait a minute, is that really the root problem here? Could we do better? And then maybe you discover, actually the problem is that people don't even think about powering on the machine before doing the washing. So maybe it should power itself on when it gets loaded or when people start pushing other buttons, right? So there are oftentimes very simple ways of applying this root cause analysis, and often there are more fundamental and more profound, deeper ways of applying it. But this is the idea. So in groups of 2 or 3, if you're sitting together in a group of 3, that's fine too. Pick out a daily problem that people face, and then think about, can I use root cause analysis to dig deeper at this until I actually get to the root problem behind it. And so a good way to do this is you keep asking why, and why are people doing this? What's their motivation for doing this? What is the underlying goal they have? It all comes back to Norman's 7 stages of action, right? Maybe you are currently looking at a problem people have by executing one of those 7 stages loops, when really what you want to address is that they have a goal that they shouldn't even be needing to have, because there's a better way to address this problem. So another example maybe, rather than, if people have trouble waking up in the morning, then maybe rather than designing a louder alarm clock, you might want to look into, how can we improve these people's quality of sleep, because they're, maybe sleeping next to a loud generator, and that's, making it hard for them to get up in the morning, right? Rather than designing a labeler that, that puts labels on all the kinds of different cables we need to plug into our computers, maybe we actually want, something like USB-C that is a cable that just works with lots of different ways of doing things, and so I don't have to struggle with the different cable types anymore. These are all examples of what kind of stuff you might look into. So I'll give you guys a couple minutes to think about a daily problem, and then apply some root cause analysis to this, and see if you can come up with an underlying issue that you can address instead. All right, let's hear a couple examples now. So, root cause analysis. Just a few examples maybe that you guys came up with. Would anyone like to start sharing one of the ideas you came up with? What's an example of a root cause analysis you did? Yeah, go ahead.
When DHL, like you get a package, but you're not there, and it just says, give it to one of your neighbors. And you don't know which.
Mm-hmm.
You leave in the list and like, in Wohnheim.
Mm-hmm.
So there are like 250 of them.
Okay.
So,
Yeah, like in a student dorm. Mm-hmm.
yeah. So first we thought maybe like sometimes there are groups and we just write, hey, I've got a package. So that's, I think that's superficial problem solving.
Mm-hmm. Mm-hmm.
But for the actual problem solving, we thought that maybe at first maybe we thought it would be good if there are package stations next to each building and you just have one, some thing you can put the package into that's personal to you.
Ah, okay.
And
So basically like a little pack station
Yeah.
next to the dorm, rather than having it at a random neighbor and then trying to hunt that down again. Yeah.
More of them. And then we thought maybe there should be some kind of basement and you can, like, for example, when you submit your bachelor's thesis, there's this thing at the ZPA, maybe something like this for each building. So you can just throw it in there, but just that isn't that loud like when hitting the ground. And it automatically scans for whom this package is, and then like it gets automatically assigned to you or something.
Ah, okay. So there's an like automatic notification that the package for you has now arrived in the great underground crypt of packages. Yeah. Okay. Yeah. So the good observation from like trying to solve the issue of where that parcel was being sidetracked to getting to something that avoids that sidetracking in the first place. That's the right thinking approach on it. Anybody else would like to share one? Yeah, go ahead.
Yeah, we were like thinking about the problem that people leave the stove on when they cook something.
Uh-huh.
And then we were thinking about what people actually want, and it's like cooked food. So maybe you could use the microwave instead.
A true computer science approach, yes. Just microwave your stuff. Yeah. Okay. No, but you're right. I think this issue that people leave on their like heating plates, the stove, is definitely it's a dangerous one, and there's a bunch of approaches. Like the first thing every engineer will come to is like, we'll do a timeout, right? It will just automatically turn itself off after whatever, 1, 2, 3 hours or something like that. You will learn that timeouts are the devil incarnate, like they're the worst thing you can possibly do, because in any interface they suck. That's a technical term. But the point with the stove plates, of course, is that what people really want is that this thing turns off when they take the food off the plate, maybe, right? So something that actually, rather than a timeout, actually detects that people are finished with their cooking through some other means, some more intelligent means, would be a better root cause analysis. The microwave, maybe, it's a very computer science student approach to solving it. All right, let's keep going. What you'll find in Norman's book, you may actually recognize this picture if you read through Norman's book, is a depiction of what happens to your design as you go through the process that we just described. Let me explain this. It's a good mental model of understanding how your design is sort of breathing and becoming wider with more options and then narrowing down again on something more singled out. So what's often happening is that we know this part, finding the right solution to a problem. That's engineering, right? You're given a problem, you solve the solution. How do you do that? Well, in your development, right? You explore a couple different alternatives, maybe different algorithms or something like this. And you find the right solution, and then you narrow down on that solution. Once you've explored a couple different options, this is where you have all the options, and you test them, you compare them, and you narrow down onto the right solution, right? And the same thing happens in the interface. Once you know which problem you are asked to solve, which one problem you should be solving, right? So you build alternatives that makes your solution space, your amount of alternatives wider, and then at this point you start testing and filtering out, seeing which one is the best option, and you end up here. And this happens, of course, iteratively with user involvement. But before that, you often have a phase that is about finding the right problem. As I just said, that's often not given to you in the real world, or people think they give you the right problem, but they may not actually be doing that. So in order to find the right problem, you need to discover a bunch of different options of what the right problem could be, and then narrow that down to find the right one to solve. And that's what Norman calls this the double diamond model of design, and that's actually, I think, something that is in the British Design Council rules of how professionals should be working. And I said that what we're doing here is really reflecting the fundamental assumptions of design thinking. So let me explain to you, like, design thinking in 90 seconds, right? Design thinking is a model that was evolving. I was at Stanford in the early 2000s as a very junior faculty, and the ideas were floating around. Shortly after I left, then Stanford actually formed like this design thinking as a formal process, and it became very popular. But the underlying things there are the stuff that we're doing here in this class. So the first building block of design thinking is empathizing. And this is roughly in order. And you will maybe recognize this is kind of like a rolled out DIA cycle, right? So these phases here are not just supposed to happen once, right? They're supposed to happen many times. And the first one means empathizing, says, I need to understand in order to be a good designer and engineer to build a proper solution for this issue. I need to actually empathize with the users. I need to understand who they are and what their actual issues are. So the root cause analysis we just did is just one example of doing that, right? Empathizing with the users. Next up then, you are in a definition phase where you're like, okay, I think I now understand what the issue is, so let me define the problem for this iteration of this cycle. Once I've defined the problem, I've sort of come to I've finished the first diamond, right, of Norman's model. And now you go into an ideation phase where you create lots of options in order to solve this problem, right? Again, thinking like a designer, opening up the design space, opening up the option space of alternative solutions, alternative approaches to doing what we're trying to do. So that, wild ideas are encouraged at this phase, right? So ideation, brainstorming, etc. We'll talk about a couple of techniques to do this. And once you've created lots of ideas, you then start, filtering out a couple promising ones from your big pile of ideas. And from those ideas, you then build prototypes. And these prototypes then, as you know, are there in order to test, right? They're a rough draft to show your idea and to test it with users, or even maybe within your design team to just get feedback on that. And then that testing is to find out, which parts of my idea worked and which parts of my idea didn't work, right? And then you go back, and sometimes you have to just go back and change your prototype. Sometimes you have to go back to the ideation phase, pick a different idea, or maybe re-explore your space more closely. And sometimes you have to go back and really say, okay, I don't think I understand completely what users are actually doing, what they really need. So there is backtracking between these stages in design thinking. Okay, so to break this down into something that, to the most basic level, if I come to your house and shake you awake at 3 a.m. in the morning, right? Laura said, yeah, like that's going to happen. But imagine, and I ask you, like, okay, what are the first 3 questions you need to ask when you're brought into a new design project, like in a new interface design project? You're brought in as the usability expert, as the interface designer, interface developer, whatever they call it, the UX pro. Then there are 3 questions you need to ask. So whatever you're doing, you need to ask these questions first, and these need good answers. If you don't have these answers, you don't have a starting point from which to launch. The question is, who am I designing for? Who are my users for the system? It can't be everybody, because designing for everybody is really hard. I mean, Sometimes it's being done, right? But even smartphones aren't for everybody. They're for a particular large part of the population, but there's lots of people who can't really use a smartphone well because, beyond a certain age, for example, your fingers get too dry to use capacitive touchscreens properly. Ask your grandparents; they will tell you about it. But if you design for, if you try to make something and you say, oh, that's for everybody, then it's probably for nobody, really. It's not a really good solution for anybody in particular. So try to be as specific as possible and try to understand who your user base is. When we went in and designed this, sick leave sheet for students to submit, it was clear that our primary users were going to be those students uploading those sick leave sheets. But of course, there was also people in the examination office who were also our users of part of that workflow we were designing. The second question is then the task, right? Users, task. What is it that they want to do with the system, right? So what is their actual goal? And this is where you try to apply the root cause analysis to get to the grounds, get to the bottom of the issue rather than solving a superficial problem. And the third one, and that's actually interesting because until, I don't know, a bunch of years ago, this wasn't on my list. I didn't have a third question to ask. But text changed really. Back in the 90s, your interface was going to be pixels on a desktop or a laptop, right? But today, technology is everywhere. We're running around with mobile devices, and so the situation of use, the context, has actually become incredibly important. Right? Today, you have to ask, as I think we discussed. We discussed this in iOS. Sorry, not here. How likely is it that my user is going to be hit by a bus while he's using my interface, right? And for mobile apps, that is a non-zero risk, right? Whereas for a desktop application, like an Office application, it's a completely different setting, right? Desktop, big desk, big screen, mouse, keyboard, blah, blah, blah. And then even when you are inside a particular setting, let's say you are in a desktop setting, is it a setting where somebody's working all by themselves, or are they together with many other people? What else is around them? Do they have access to file folders and to a calendar on the wall and all these kinds of things? So the entire setting, how likely is it that they get interrupted by a phone call? So the whole context of use is really important to understand as well. So users, task, context are the three things you need to ask yourself, and you need to ask the design team, and you need to probably involve users to find out about this in order to answer this. If you don't answer this, there's a good chance that your project fails. You may build something, but maybe it's not for the right kind of people. Maybe it's for a different task than what people need to do, or maybe it's for a different context than what people are actually in. So, and that's where it becomes sort of, inconvenient for us computer scientists, right? We actually need to talk to people for finding out about these, okay? So this requires asking. You can't just make wild assumptions on these, okay? You need to find out. You may need to observe people. We need to talk to them. This is something that people find tricky, but it's super important. So 3 a.m. in the morning, I shake you awake, like, what are the first 3 questions in your UX project? You're like, who are the users? What's the task? What's the context, right? Then you're good. All right, so users, who are the users? What does that question even mean? There are a bunch of different dimensions along which you can classify and profile users, and we'll talk about a couple. The most central one is, of course, experience. But experience is a tricky beast because it's not as simple as you might think. We could say, well, we have newbies, they don't know the task at all. So for example, somebody who comes to the Deutsche Bahn ticket machine in the railway station for the very first time in their life. They've never seen it, right? That would be a first-time user. And they don't know how this thing works at all. Or first-time users could be people who don't know the UI, in general, and so they have a certain amount of anxiety to make mistakes, right? So for these people, you need to, of course, make your user interface particularly simple to use, reduce the feature set. You need to make your vocabulary of use, and that's not just words, but that could also be like an icon set or concepts in your user interface, right? Like files and folders, something like this. It needs to be small and consistent. And the feedback needs to be rather a lot, rather too much than too little. So give people good feedback so they always know where they are. They need good help systems available so they can always figure out what's going on if they don't get what's happening, and documentation, of course, as well. Then as people advance, the average users would be somebody who uses, for example, uses a software a few times a week. Let's say in an office there's a software to, for example, we are using a software to book things that we bought, right, into an inventory system. Yeah, and usually, somebody working in the office might be using that, about a couple times a week, but maybe there are weeks where they go without having to do any work with the software. So they know the task well, they know the UI, kind of. They will probably forget functions if they haven't used it for a while, right, and come back to it. So here, your UI can get a little more complex, but you want to focus on, since you now have probably more functions and more features available, that you structured well in, for example, in the clear menu structures, or whatever the ways that you offer your features. Consistency becomes a bigger issue because as your system grows in complexity, you need to make sure that you still remain consistent. For example, if you're doing a music app, are you always calling a song, or is it sometimes a song, then it's a title, then it's an audio file, then it's an MP3 file or something like this. So these things need to be worked out. Or is there consistency about, for example, deleting stuff in your system? Does that always work in the same manner, or are there completely different processes for deleting a song versus an album versus something else, like a playlist, for example? That would be bad. This is where GUIs, of course, really begin to shine because as we now understand from what you learned about human perception and cognitive processes, if I offer somebody a GUI where they can pick from a menu list and do one or the other thing, it's much easier than having to remember a set of textual commands, right? Which you would do on a terminal, like on a command line in Unix or on DOS, for example, where you have to type in, cd blah 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 ls. That's okay if you use it, a lot, but if you haven't used it for a while, you're like, okay, what was the option again to list all the files in my directory? Right? It becomes much easier if that is being shown to you in a GUI and you can just pick it, because that helps as it's externalizing knowledge, right? It's knowledge in the world rather than in the head. And you need to continue to protect people from errors, of course. Also, as systems become more complex, it becomes more likely that error situations can pop up. And people need the protection from those situations. And then finally, you have experts, right? So let's take an airline reservation system where somebody is like working actually at a travel office, and they do nothing else the whole day, right, than doing airline reservations. These people will be extremely expert at the task, and they will use the UI for hours a day, so it needs to be very effective and efficient, right? Speed becomes an issue, right? Or take people who work at a hotline, right? They work at a hotline, and they need to file hotline call-ins, and they need to access the company database for solutions that people are asking. These folks are under a lot of time pressure, and they need to get this stuff done quickly, right? So there, for example, you want an efficient and speedy interface. And for example, a command line-based interface may just be the right solution. I've seen comparisons between the graphical way that you pick, for example, flights on like a traffic website, like, I don't know, Flüge.de or something like this. And then there is the so-called START system, which is, has a command line interface that travel agents use. If you see that, you think they're like writing machine code or something. Like they type in these cryptic sequences, but that sequence says that I need a flight with a maximum of 10 minutes layover, and it's for 2 people. One of them has special dietary needs, and it needs to be on this airline with this special whatever frequent flyer state. And they type all this in like in a long line, and they get the results, right? This would have taken them way too long to configure in a GUI and go through and click and pick all these things. So if you're doing this, this is what you do all the time. Oftentimes, maybe a textual command line sort of infrastructure is better. Or maybe you want a GUI, but you want to be able to really, optimize it for your needs with shortcuts, with keyboard macros, where you can trigger many things in one go, where you can write little scripts to drive the UI. It needs to be customizable. You may be able to throw out a whole list of things to make it more efficient for your needs. You may want to add things, extend it. So you can see from this description alone, one and the same user interface is probably not going to cut it for the beginner and the expert, right? It really becomes hard. So that's why it's important to answer this question. But experience is not the only criterion, right? There's lots of other dimensions. For example, you can take the background of people, like their age, education, can give you actual hints on where things are, whereas income usually probably doesn't make a difference in terms of how they use the system. Their name is not going to make a difference. Nationality may or may not make a difference, depends on, for example, how proficient are they with the language you're using in the interface, like the actual spoken language. Other stuff is just collected if you need it for your own statistical purposes. But then more interestingly is computer experience, right? So you can actually distinguish between how experienced are people using a computer, a particular app on it, or computers in general, right? That's the difference. And one way to figure out computer experience quite well is to ask, like, how many hours per week are they using it typically? How deeply are they involved in using special functions? For example, do they know all the options in printing things, or are they just using the most general services? And then separate from that is task experience, meaning that people might have actually, for example, let's take an architect who's been an architect for like 25 years, so they know exactly what they're doing as an architect, but maybe they've never used a computer, okay? So they are very new in terms of using digital tools, but they know exactly what they're doing in their actual job, right? So that is 2 separate parts of experience, 2 separate aspects of experience that you should tease apart and distinguish. And finally, there's also personality questions. So while every person is different, of course, you tend to have sort of trends in your user base. For example, if you're developing a system for finance accountants, you're probably going to encounter a different personality type than if you're designing a system for, let's say, performance artists. Okay, one tends to be maybe a little bit more on the introvert and on the more organized side, a lower risk threshold, more systematic. The other one maybe more extrovert, more spontaneous, and have a higher risk threshold. And people might be early adopters of technology or late adopters of technology. All these things will play in there. And here's the tricky thing. If you don't if you don't go through the process of thinking about your users in this way, you're going to assume that your users are kind of like yourself. And surprise, surprise, they're probably not, right? We are a special bunch, okay? As engineers, as computer scientists, as people who are drawn into this field. That's why you're here. You're studying computer science or a closely related field. That is already a selection process that has happened, right? So everybody here in this room has actually probably more in common in their personality profile than you may be different from each other. So the second thing that happens in your education here is that you're getting socialized with all these other people who tend to think a little bit like yourself, and that's cool, right? So you're comfortable with these people. They also are interested in tech, and they also like to play with the latest gadgets and whatnot. And now you develop stuff for people out there, and they may be very different. Doesn't make them worse. Please remember that, right? Doesn't make them worse people. Makes them different, probably better in many ways than us. So be aware of this, and this is what empathizing with users is really about. Stepping outside your own comfort zone and understanding that the person you're developing for is likely different in all these things from what you are. So that's ways to classify, but how do we find out? Well, one way to do this, and that's incredibly educational, is observing users. When you observe users, you will learn a lot. I have never in my entire life experienced a single session where I've observed users using a piece of tech where I haven't seen something that baffled me, where I was like, what? That's what they're doing. This always happens, and you'll be surprised. You will always learn something, I promise you. So when you go out, you might think, why do I need to observe people? I don't have a design yet, right? Why should I observe people to test it with? Well, you don't need a design to start observing people. There's lots of designs out there, and you can learn about the current tasks that people are doing by just observing them with the tech they already have. So, the ticket machine, you go to the Aachen main station and you observe people using the ticket machine, you're going to have fun. You're going to learn so much about what people are doing, what they're not doing with this thing. It'll be interesting to really grow this. So don't assume you know all the issues about the ticket machine. You may know a couple because you've used it yourself maybe, but you are just one user with this very specific profile. And all your skills are it's a different profile from everybody else out there. So you need to observe a random sampling of people, right? So when you go out and observe users, you shouldn't just go there and say, oh, let's see what happens, right? That's not very effective. You want to set yourself some goals. How will you analyze the data that you observed, for example? What are you planning to do with it? Do you need video recordings? Do you need audio recordings? Are you going to write something down? Do you need timestamps in your written material so that you can match it to the recordings? And then who will you actually observe? Who are you planning to look at? Just the people using the machine, or also the person who's doing the maintenance on it, or the whole family that is standing around it, or just the main user who's booking something? And then a great approach to make sure that your observations are covering the ground well is what we call triangulation. So you use different sources. You don't just observe, because observation means that you don't really talk to people, right? You just look at what they're doing. You may also do interviews with them. So when you talk to somebody and ask them about their job, they will tell you why they do something, so you can draw out interesting information. But when you actually observe them, you will really see what they do. And that's actually often a little different, right? So you may find people telling you one thing and then doing the other, and that's very important to notice. In order to debug your observing, you may want to do a little pilot. A pilot is always a great idea for your studies, for your observations, and an observation is just another form of a study. You do a small-scale version of it with a bunch of people to debug the process of what you're doing. That you notice, like, oh, I should have brought a pencil and paper, right? You don't want to find out about that when you're like on your big day. So here's a framework that gives you this is taken from the interaction design by Jenny Priest. By the way, that's from 2011, not 2001. Maybe you can make a note, Ricardo, that we fixed that year. The book Interaction Design by Jenny Priest is an interesting one. It tells you a lot about these processes. And one of the things it has in there is an observation framework. Simply put, it's about people, so who's using the tech, places, where are they using it? So this is about context, as you can see. And things, what are they doing with it, right? What is actually happening with it? Let's unroll this. For the ticket machine, for example, what's the physical space like, and how is it laid out, right? So this would be like the ticket machine in the middle of the, Aachen train station, and it's busy. People are walking around there. You're not very, it's not a very private space. It's loud. It's noisy, so that gives you an idea of what the space is like. Who are the actors? So they've got somebody who wants to buy a ticket. Is it, are you just looking at a single person buying a ticket for themselves? Are you looking at maybe a couple buying a ticket, one person buying tickets for both people, or a whole family, or a group of friends, or whatever? Find out about the details, as we just said, about classifying users. Next up, what are they doing, and why are they doing this? So one is, obviously they're going to be pushing touch screen buttons on this interface, but why are they doing that? What are they trying to do? What physical objects are there? In this case, maybe just the ticket machine, right? There's probably nothing else. But is there a bench on the side, for example, where they set down their stuff while they're working the ticket machine or not? Is there any particular openings, flaps, where they need to take out tickets or put in money, etc.? What are specific individual actions? So that's when you get into, okay, so they are obviously looking for, maybe you find that they look for a destination first. So maybe they look for return versus single trip first. Or maybe they look for, I have a bond card, but I don't have a bond card first. Who knows? And then also, is what you're observing part of a special event, or is it more of a recurring thing? So somebody might be using the ticket machine and might run into trouble because currently the network connection of the machine is down. That's hopefully a special event, not a regular one, right? And that should be noted differently from the predominant everyday interactions there. Or maybe they come there and they are renewing their, annual pass using the machine, right? Which is also a more special thing than just buying a ticket for an everyday trip. The sequence of timing of what's happening when is important, right? So take some timestamps on, for example, how long it takes to get from, starting to select something until they leave the machine, and what are their goals, right? According to the Norman thing, you want to hopefully understand what are they actually trying to accomplish. And finally, if you can catch a vibe on that, what's the mood of the group and of its individuals, right? Again, in the case of the ticket machine, they're probably in a hurry. Whoever gets to the train station buys a ticket and is not in a hurry, I don't know. So those are the kinds of things that you want to catch. All right, I'm going to show you a video that I really like. It's a video that people did at Xerox PARC, about the use of projectors. So what you're going to see is somebody will explain to you what they found in this study, and you will see they recorded things during normal meetings at PARC of people using projectors. So you might think, projectors, what's the big deal? It's a remote, you turn it on, you plug in your computer, and that's it, right? But look at this study, and I think it's a very well done study that carefully analyzes what happens when people use projectors. And some of these things you've probably experienced yourself, but you've kind of blended them out because they were annoying, stressful, embarrassing situations of you or somebody using a projector while you were in the room. But this brings out all these little issues that are there. You'll also see sometimes they have users explain to them, or one user explaining to another one what they think is going on, some user trying to help another user while they're struggling with the projector to be set up. So it's a wonderful little study, a couple years old, so maybe some of the issues are different now. So you can maybe also pay attention to what you think has changed in the meantime. So let's roll this video.
Projectors have become ubiquitous. Indeed, at PARC, projectors are installed in every conference room. Projectors are simple, single-function devices, namely, to project an image. And since the desired image is already shown on the computer monitor, it is just a matter of projecting the same image on the wall. So why are they so difficult to use? Right away, the problems start. How to turn it on? Because many projectors are mounted on the ceiling, people need to use a remote control. Most users do not know where the infrared receiver is, so they start pointing the remote to the projector and hit a power button. But most projectors do not give feedback to users that it has been turned on. maybe only a small LED light. But it is not visible for the user 15 feet away, and it takes time to warm up and project the first image. Users are often unsure whether it is even turned on. Once an image is shown, users need to worry how good the image is. In many cases, the image is cut off slightly. Still, the audience can see most of the image, so people often do not try to resolve this issue and continue with the presentation. Yet because the problem visibly remains, it becomes more and more annoying. With one particular type of projector at Park, a cutoff image is often resolved by selecting Auto Adjust on the remote control. By now, many people have been told to use this when the image is cut off. Yet, this button is just as small as the other buttons. Unless told to use it, not many people can figure it out. The resolution can be different, so that the icons on your desktop no longer appear in the same place. When the resolution is set back to the original setting, icons are moved to different places. The problem, perhaps, is that this often happens automatically when the display cable is plugged in.
I shut my computer down, and here it is. See, it moved my icons around.
Yeah, because you resized your screen.
No, I didn't do it. I didn't do anything.
Users think they did not do anything. They typically start to find something to blame, often the visible piece of equipment, like a projector. In some rare cases, the image is off the screen. Nobody knows why this happens. Some try to resolve this by changing the setting with the remote. But another person climbs up on the table and adjusts the projector by hand. Turning off the projector is not without problem. When a user pushes a power button, the projector somehow asks yes and no, but there is neither a yes nor a no button. There can be vexing issues like video inside PowerPoint not playing, or the sound not playing from the speakers in the conference room. In this particular case, the video is shown on the laptop, but not projected.
There's no audio.
It's not showing.
It's not showing? I have this excellent clip of Jerry.
You might have to change the resolution.
The colleague started to change the resolution.
Okay, so I wanted to show you a clip of shadowing, and it was...
The presenter had to change the course of the presentation and fill the time. In this case, they changed it to the two-screen mode, or extended desktop mode. This allowed the video to be projected. The two-screen mode has its own problems. Users often cannot find the cursor.
You just scroll the cursor back to the left.
Scroll the cursor back to the left.
Keep going. Keep going.
It is also not clear which screen PowerPoint slideshow will go to. In many cases, slides are shown on the laptop, not to the projector. What makes this so aggravating, of course, is that it must be done right in front of an audience. When the meeting is informal and internal, this may not be such a big deal. But when it is in front of senior managers or clients, it can be downright embarrassing. Even without a problem, actually, switching from one computer to another takes about 30 seconds. When the audience is quietly looking at the presenters, 30 seconds feels very long. Maybe what is needed is a little CNN button on the remote. When there is a problem, a user can hit this button to show CNN News to entertain the audience while fixing the problem. The problem causes more problems because of the projector's public nature. Everybody can see that the presenter has a problem. The audience typically tries to wait at first, but after a while, they start to offer help, suggesting some fixes. For instance, when John was troubleshooting, a lady came and said,
You probably need to do your F key, function key.
This only distracts him because he knows the problem is deeper than that, but feels obliged to acknowledge her help. Finally, he lets her do what she wants to do. Of course, this does not work, and finally the presenter says,
we don't need to, it's not that important.
The problem with the projector is already frustrating, but once new social problems are added on top of that, it becomes impossible to troubleshoot properly. In the end, the presenter gives up presenting. Another social aspect of projectors is that they essentially display whatever is on your desktop, and people often do not think about this when they first try to display. The public nature of a projector and the personal nature of a computer collide, so that when the picture appears on the screen, your emails and the files you download from the internet are there for all to see while you quickly try to start up your presentation to cover it all up. When you type a URL in a web browser, you need to be careful because the browser kindly shows recent URLs you have used. To make the problem worse, nobody owns a projector. A laptop computer is owned by somebody and taken care of. People simply use a projector that is available in the room. Nobody checks batteries in the remote, for instance, or cleans the air filter. On top of that, nobody makes an effort to learn about a particular projector by taking a class or reading a manual. Nonetheless, people rely on projectors more and more. Summarizing what we have seen, we can point out some key issues. First, usability is a much more complicated issue than it seems. We have identified a number of usability issues that should help designers improve the products. Particularly, users need to be given appropriate feedback in the right form. Second, we saw a number of problems caused not by the projector itself, but by other devices like a computer, a video player program, and an audio system. It is true that projector manufacturers are not responsible for these problems. But from the user's point of view, they do not blame their computer they are familiar with or the audio system that is hidden under the table. Projectors are the first to blame. Third, we need to take the social problem seriously. Projectors have a special social status as a public device. The ways in which users react to projectors are different in front of an audience. Designers need to take this social nature seriously.
So, I'm guessing most of you have seen at least some of these issues, right? Seen private content being displayed on the big screen and all that kind of stuff. And if you've done seminars at our lab or anywhere else, you've also been in this wonderful situation, struggling with the projectors. What I wanted you to reflect on is that these people that did this study were filming folks using the devices, right? And they empathized with their users. They tried to put themselves into their shoes. They noticed emotional distress, for example, of people as well. And some of the things that I think are worthwhile noticing about the video here is this is actually a case of fairly reflected observation. It's not just showing problems, but it's also trying to understand why are these problems coming up. It's looking at the whole social context, including things like embarrassment, which is only something that really occurs when there's more than one person in the room, really, right? And it also shows that interface design is complicated, even with something as simple as the projector. So this is one way of doing things and finding out about people with observation. The other approach is the interview. So it's great to observe people, but you don't get to actually talk to them in your mere observation about what is going on, right? You typically don't interact with them much. And so for interviews, this gives you the other angle. Like this is about this like multiple angles at things, a triangulation. So let's take a, I don't know, the example could be maybe Amazon wants to design a new ebook reader and they want to figure out, should this thing also feature audio playback or not, right? So they might be asking users about like, okay, so what do you think about audio playback in an e-reader? And then of course customers would say like, well, yeah, why not? But that's not a good way to run an interview, right? You want to actually ask more concrete questions, right? So you need to actually think about an interview protocol when you do an interview with people and think about what will you be asking. So for initial input, in fact, it's useful not to focus on your design idea in your interview, but actually just on learning about the task. And you won't believe how many people make this mistake, right? They go into an interview and they say like, wouldn't it be great if I gave you this new cool thing that I'm building? And then the user's like, I guess, you know. That's not what you're trying to do, right? You need to go in and it's like, I want to understand how you work today, right? That's my task with this interview, is to understand this. You're really more like an apprentice there, understanding the task. Again, interviews, like normal interviews, would be run like with a pilot study, of course. That makes perfect sense, where you, for example, interview one student in your group and have a separate person to notice any pitfalls and make notes on this. So there should be a 3-person thing to do. You know, if you, for example, go through with this idea of, let's say, you want to interview people about the idea of an ebook reader with audio, you could ask folks like, okay, so you know, so we're not talking about like audiobooks, right? We're talking about like music while reading, right? So the interview could say like, well, so do you listen to audio? And then maybe somebody says, yeah, a couple of times. And then the interviewer might say, well, do you listen to audio while you're reading? Is that happening? And if so, when is that happening? And then maybe customer says like, yeah, I do this when I'm on the bus, right? Then I'm reading and there's also audio. And then maybe the interview says, okay, so why are you doing that? You know, a little bit of root cause analysis, understanding what's going on. And then maybe the customer says, well, it's because on the bus it's pretty noisy and that's distracting, so that's when I'm putting music on while I'm reading my ebook. You know, next up you could say like, well, is it always distracting on the bus? Well, really more in the, you know, when the bus is really full in the morning. In the evening, you know, everybody seems to be pretty quiet. So the takeaway here is follow-up questions in the interview are useful, right? You have a profile, you have a list of things you want to check, but in the interview you will have to react to what the interviewed person is saying. Don't just listen and record the answers, but react to these and try to come up with follow-up questions, digging deeper into things that people are telling you. Brings me to the question of how to ask questions. Questions need to be, you know, not too broad, you know, fairly clear, fairly simple. It's actually an art to elicit interesting information from users in these interviews. How do you like the UI in general is way too generic, right? That won't give you much useful insight. So you need to be more specific about what you're asking. You will also find that users don't always answer truthfully. And one of the reasons is that people just don't know, right? If you ask somebody, so how many hours are you using your email client each week? I would have a hard time judging that, right? I wouldn't even know. So I would take a wild guess, and maybe that's off, right? The second reason for that is I might be embarrassed, right? If you ask me, so how many hours a day are you spending on social media? And then people might say, oh, yeah, like 2 hours, when it's really much more, and they know it's kind of much more, but they don't want to say it because it's embarrassing. So that's something to be aware of. So you need to formulate your questions very carefully, maybe sometimes indirectly, like asking them, for example, instead of asking people, are you a novice or an expert in using Microsoft Word, you could ask them, well, have you used the function X already? Have you created serial letters with different addresses in Word? Or have you done this in the software? So that will give you an insight, for example, into whether they are pros or beginners in this. Leading questions are the most dangerous part, probably, of interviews. So, you know, do you like this new interface design that I spent my whole master thesis developing? And by the way, if it fails, my life will be over and it's miserable. So that's not a good way, right, to get people into this. So you want to make sure that you don't lead people towards certain answers, right? So. So that was the example with the audio. You know, the leading question will be, do you want audio playback in an ebook reader? Because then people will be saying, yeah, sure, right? Ask people indirectly and ask them so that they are not biased in any particular way. Better question might be, what I just described as a sequence of questions that could be asked. With your interview results, what do you do with this? Well, you get a profile of your user, you get a profile of tasks, you get, if there is a system involved, you might discover problem areas with that system, like what's not working with the system. You might also get back ideas for improvement, right? Things that people can change. In our case, like an idea for the task that our system should be supporting, right? If we ask people before we have a system available that we're designing. Now, one way to work with your user data is to just take it as face value. It's like I've talked to 20 people and this is all the data. But that's a very rich data set, right? What has been come up with as a way to take all that information from the users and condense it down to a small package that you can use in your design team is the concept of personas. Personas are, they're people, but they're not really people. What I mean with this is it's an aggregate of what your findings are. And a persona is a fairly detailed description of a user, but it's a hypothetical user. So that particular person doesn't exist, right? So here, for example, this is also taken from Jenny Priest's book. Like this is a sample user representation for a teenage user of something. And so you can see there's a fair amount of detail about this person, about their background, her motivations, her frustrations, and what how she's what she likes, what she doesn't like. There's a photo, but all of this is fake in the sense that that person doesn't actually exist, but it's drawn in from what you've learned about your user base. So it represents somebody who could have very well been one of your users. Why do we do this? This is a stand-in for real users that you can use in your design discussions to reflect on, are we doing the right thing here for our user base? If you have this, then you can always ask, well, would Ginny like that feature? Right? And everybody has then a person in their mind and then can think about this. If you don't have anything like that, it's very easy, again, to slip into this habit of, yeah, I'm sure the users will love this, right? Because you don't have a concrete user in front of you. So everybody has their, a user in front of them that fits their own agenda perfectly, right? So instead of having sort of, assuming that people have all these abilities, all these, that they, for example, have no particular preferences or dislikes of certain things, you have a concrete person with her own particular needs, right? So zooming in on this, you can see, if you read through this real briefly, you'll see this actually captures a bunch of things on her characteristics of that person. Some people actually go to the extent of creating like life-size cardboard figures and then putting them into the corner of the design team's meeting room. So every time you have a discussion, that there's like a user representative is in the room, so to say, right? You may not end up with just one persona. You may have multiple personas for your primary user base, or you may even have, for example, let's take our students' registration thing for like sick leave. You might have a representative persona for the student. You may also have a representative persona for somebody working in the central examination office, right? So that's a good approach of capturing what you know about your users. Now let's move on from, this is sort of analysis, right? Understanding your users. Let's move on to the first design technique, which is plain old brainstorming. And I'm sure you guys have been doing brainstorming before in projects, whether at school or here at the university. I just want to reiterate how it should work and some of the things that easily go wrong with brainstorming. Brainstorming has a goal. The goal is lots of ideas on a given topic. It's not about the quality, right? So it's supposed to be a relaxed, fun thing. It's a good idea if you know somebody who's good at brainstorming. There's a certain talent to this. Then you might want to invite those people. And you defer judgment, right? So when somebody says, oh, this is an idea, blah, 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 you don't start criticizing that, but instead you just take that as it is, write it down, somebody writes down all the ideas, and then you build on top of what they said, and you come up with other ideas. So there's no arguing, a discussion, there is just collecting ideas. So you leapfrog on each other's ideas. That's what the idea behind that is. The quantity is important in brainstorming, not the quality. You might go actually for a certain number. Like I want 100 ideas for the app that we are envisioning as our project. This helps you really push for quantity and not be too critical with yourself with your ideas. Crazy ideas are welcome and included at this point. We are broadening, right? In this double diamond model, we are broadening the range of options that we're exploring. We're not narrowing down. You get somebody to write these down. It's actually a very good idea to do this not just on a piece of paper, but do it somewhere so everybody can see it. Why? Because let's say we're 5 people brainstorming, you say something interesting in the beginning, and then you say something else, and it all gets recorded on the board, and then somebody's a little bit like, yeah, kind of out of ideas, but I might look at something that you said and like, oh yeah, that brings me to a new idea. So leapfrogging on each other's ideas is easier if everybody can see this in front of everybody. Today, if you're doing this online, you might use something like a Miro board or something like a shared whiteboard. If you're in an actual physical space, you use something like that. Or if you're just 3 people around a table, you might also use just a big piece of paper. The biggest mistake in brainstorming, apart from us being very German and criticizing everybody about every idea they put out, is that we go too long. Right? Brainstorming is something that shouldn't last longer than 5 or 10 minutes. Because it's a high energy task that actually will exhaust you after a short time. And so to help you brainstorm, if you have trouble getting the creative juices flowing, there's a couple interesting approaches. One is to think of positive or negative habits, for example, to think of physical gadgets or how the habits can be linked to them, and to stick to a particular domain. For example, diet, exercise, drinking, smoking, hygiene, etc. And try to answer these 3 questions. Who is doing it? What are they doing? And where are they doing this? If you're trying to brainstorm, you can just brainstorm a couple of different user profiles or a couple of different tasks or a couple of different contexts that you might want to use this in. We're going to take a sample, a topic here, just out of curiosity. So I would like you guys to get together in groups of, I would say, let's try roughly 4, plus or minus 1. Let's brainstorm a couple ideas. So you need a piece of paper in front of you. And we're going to take a problem called how to motivate people to clean their rooms. Okay? That's your task. Create as many design ideas as possible, how to do this with some kind of system, app, solution, design that you come up with. It could be anything. Include your crazy ideas. You got plenty of ideas now. So now you might be wondering, what do we do with those, right? What's next is to structure your brainstorms. Once you have your brainstorming, you end up with a lot of stuff on your table, and we want to sort this in some way. We're going to do this with what's called concept mapping, or sometimes also known as mind mapping. It's been around for a long time, since the Middle Ages. Mind mapping is the term that most people know, but it's been trademarked by some guy, so we use concept mapping instead. What you're doing is you're creating a visual layout of your notes, structuring it, and mind mapping or concept mapping can be used for lots of different purposes. For taking notes in a meeting, for planning something, for learning. You give your notes a visual shape in a way. What you typically want to use for this is a big piece of paper, ideally even like A3 landscape, so you have lots of space. You put your subject topic in the middle, and then you start creating branches out of that for your different aspects, and your subtopics go onto sub-branches from that. You can use software for this, although I would recommend for the moment to stick with pen and paper, because that's the easiest and most direct medium to work with, and it doesn't slow you down as you're doing this. what you end up with is sort of like a tree visualization with the root of the tree in the middle and then the branches going out to the side. I'll show you a picture in a second. And oftentimes you will find additional links between topics that then are sort of linking branches with each other as additional connections. It makes sense not to just use words in your concept map, but actually try to add a little bit of iconography to it, a little bit of images. We'll get to how to do that in just a few minutes. And to use colors. For example, different branches can be different colors. Connection types can be different colors. After your sort of pencil version of a concept map has become kind of stable. Concept maps are not static. They can grow over time, or you can combine individual maps into a big one. So there can be a living being that evolves over the time of your project. This is actually, I'll show you an example. I think this is the best way to understand this. This is a concept map that people did years ago in this class on the topic of interactive large public displays. The topic was come up with ideas, projects that use interactive large public displays. And so you can see what they did is they took a couple aspects, like they could be used for entertainment, or they could be used for information, socializing, or for things like puzzles down here. And so you can see these are the main branches, and then inside these, for example, inside the branch for information, we can see that they can be used for navigation, or news, or event schedules, or blah, 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 lots of different other ideas. And then event schedule branches off into even more sub-branches up there, like cinema, concerts, sports, politics, commercials, blah, 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 parties, etc. And what you also notice is maybe a little bit of shading has been going on with different colors here. The emergency case has been done in red here to make it stick out in a different color than the entertainment branches in yellow. You also see at some of the ends, some of the ideas are being sort of written down. So for example, here for drawing and painting, they've put down a pencil here. For the idea of help calls, there's this, like, oh my God, help call logo here. There's one for message boards with a message logo. So using some simple iconography to paint this. Here's also an example of a cross-link that sort of creates a links between branches of different subparts of that tree. What you can do with your own ideas that you now have on your board there is to classify them into one of those maps. So I would like you to take just 3 minutes. Take just a piece of A4 paper in landscape and take the ideas on your post-its and arrange them into clusters according to this and come up with some names for this. See if you can come up with a concept map that sorts your ideas into these sub-areas. You can copy them off from the post-its, or you can use the post-its on your table and cluster them according to proximity. That's totally up to you. All right. Thanks, everybody. I saw some good structure emerging. Sounds like the different, whether we're giving people positive sort of motivation to get started with cleaning, whether we make the job itself easier, or whether we punish them, as you said, whether we bring out the more negative aspects of not doing the job, or is one way to cluster things. But there are many other approaches, right? Let's move on. You'll be doing more of this with your prototypes that you'll be doing in the next couple of weeks. But I want to move on to the last part here, which is going to be a lot of fun, I hope. This is about storyboarding. Storyboarding is, after we've talked about users, we focus on the task, right? And a storyboard tries to capture, a storyboard is a bit like a comic. It tries to capture in a sequence of little images that you will draw. Yeah, panic in everybody's eyes. In a sequence of little images that you will draw, it captures the essence of what's going on, what people are doing with your system. It's like a visual outline of a film, or like a representation of a script, it illustrates the interaction. If anybody's watched any of the DVD or Blu-ray extras, that you get when people show you how they've done like an animated movie by just doing still images first, right, and tell the story. This is what you're doing with the storyboard. And again, the storyboard has a purpose. It's there so that it describes the task, it shows the environment, and it shows hopefully also some part of the user, even if it's just their hand or something. And I'll call it the computer, whatever the technology is that may be involved in your system. It may also describe the UI itself, if it's more like zoomed in as a series of still images of screen captures, basically, like a screen photo. But still, you try to get your user in there, even if it's just with like a finger or mouse button, a mouse cursor doing things. This really helps you to work out your interaction details and gives a great overview at a glance of the interaction. And I'll show you an example in just a second. This thing also will help you develop your further like usage scenarios and tasks and tools. When do you do storyboards? After you've described a task, you can do a storyboard, and then you take that storyboard back to the user. Remember, a storyboard is a prototype is a question. So you go back to the user and ask, did we get the story of this usage right? Is that a story that sounds promising to you? Like, would you be, does that sound like a positive use case for you? Here's an example that I brought over from my Stanford days. Back then, this was in 2001 or something. So we asked people to come up with ideas for augmented reality tech, I think was the topic. So here we have a story. And I'm going to tell you the story that the student group came up with. Here's Bob walking somewhere on the right-hand side. And there's a guy on the left. He says, like, hi, Bob. But Bob has trouble remembering faces, so he doesn't recognize this other guy who is Tim. And so Bob starts like, so how is your wife? And Tim is like, what wife? I don't have a wife. So Tim is upset. He thinks Bob is a moron. So that's the bad way of things going, right? This is without what this student group called the recognition glasses. Now the lower comic panel shows Bob wearing his recognition glasses, right? So Tim comes up, hi Bob, and Bob, looking very sporty with his glasses, immediately registers, okay, the glasses register, this is Tim Brown, right? So they show Bob, this is Tim Brown. And then, Bob remembers Tim has a startup, brown.com, and okay, this was 2001, right? So he's like, hey Tim, how's your startup doing? Oh, it's going great, Tim says, like, want to grab a coffee or something. So they kick it off really great. So happy ending, right? That's the idea of the bot. So don't worry too much about the recognition glasses, right? Whether it's a great idea or not. But what I just did was in like 60 seconds, I pitched not one, but actually two stories to you, one without the tech and one with the tech. And you kind of got what my plan was, what I was trying to do. And now we can have a conversation on it, right? That's the point of a storyboard. Now the problem, of course, is you need to draw it. Now everybody get out a piece of paper and a pen because we're going to draw stuff. I'll be frank. I am not an artist. I think it was in 5th grade when my teacher said to me after we had to draw something, she said, Jan, you've got really great grades and everything, but you should never become an artist. Like so. But that doesn't matter. You don't need to be an artist to do this. We're going to start with the worst thing. We're going to start drawing people. And so how do you draw people? You'll probably recognize, and I want you, as we do this, I want you to draw along with me, okay? So whenever I draw something, you do a couple of these, and keep drawing more of these. Can you turn the lights at the front on? The first thing is drawing a person. So we're all aware of this is how we draw people. Like this is how we've been drawing people like we were 3, right? That's Stickman. That's not very evolved, right? We can do better than that. I'm going to show you Starman. Starman works like this. You all know how to draw a 5-point star. Let me draw a 5-point star to start with. I'm 1, 2, 3, 4, 5. And now you see, you just need to distort this a little. So draw the star, but keep drawing while I talk, right? So you've got a head up there, and then you've got one arm, and then you've got one leg, and then you've got another leg, and then you've got another arm, right? And then the sky has maybe 2 eyes down up here, and maybe a little smiley face. So you've got a guy, right? This is Starman. This is already better than Stickman because it actually has, 2D area rather than being little sticks. And you can do a few things with Starman, right? So keep drawing Starman while I talk, right? So you can have Starman be, very happy because he's got his arms up like this, right? He's like, yay, very happy. Or you can have him, you can have a little Starman family, right? He can be one guy here, and then there's another one here. Oh, that that looks bad. I'm going to do it like this, maybe. And then there's a little kid down here. What you'll notice is also the bigger you make the head in comparison to the rest, the more it will look like a child rather than a parent, like an adult, right? So there's a couple things you can do with Starman. The next thing I'm going to show you is Starman can be pressing a button, right? So they can be reaching out to the side, right? So for example, you can have him like this, and then the arm goes out like that. So he's like, operating that thing on the wall or something, like, using some kind of user interface. We have next, So sometimes Starman is still too much work. Like if you need to create a lot of people quickly in your sketch, you might want to do Star Trek Man. Star Trek Man works like this. You do the Star Trek logo like this, and then you put a head on top, right? Yeah, I know it's not exactly the Star Trek logo, but hey, it's close enough. So this guy has a problem. He doesn't have arms, but it's pretty quick to draw, right? You don't need to do as much work with this. So let's say you want to do a scenario of something that is even simpler than that. If you don't want to do Star Trek Man, then you can also reduce things down and do the simple Star Trek Man, which doesn't even have the closing thing down here. So that's the most simple thing that you can do, right? This. That's a person, right? If you really need to be quick about it. Keep drawing, guys. Don't look at your computer. Keep drawing on a piece of paper, okay? So if you want to say, I need to fill an audience with in a sketch of like I'm doing a presenter software or something, so I'm going to put an audience into a room, right? You can do this really quickly, right? There's a lot of people sitting in rows, and then there's maybe somebody up here, he's doing something. So this already gives you a way to quickly bring people into your drawing. Next up we have, for example, Architect Man. So architects, they're always really good at sketching, like most of them, and then they always envy them. And one of the tricks they use is they scribble a lot, and it looks so cool. So you can do that too. If you want to draw a person, you can also do this, right? This is what people do as architects. They have this like scribble technique, and that gives you a person, right? Like that. That looks very, very, very fancy, and lets you. By the way, this is they use the same technique to draw trees, right? So if they say, okay, now I'm going to put a tree next to that person, and they go like, okay, that's a big scribble, and then more like that. So there's a person next to a tree, right? And so that's the secret technique of architects drawing people. And if you want to do suits, if you want to show like business users, you can maybe even do like this kind of shape, right? That looks like they're maybe wearing suits, or maybe they just look a little stupid. I don't know. That's another way of drawing that. So that's how you can put people into drawings. And now the next thing, of course, is hands, right? Hands are the other nemesis of the computer scientist, right? Drawing hands. You got to get the number of fingers roughly right, otherwise it looks freaky or like an AI-generated image. But there's a fairly easy way to do that, right? So again, our like childhood hand is like what? This like thing with 5 pokes sticking out, right? We can do a little better than that. What you can do is actually just scribble it in a way that it's doing something. For example, if it's pushing a button, then you can do like the finger reaching out, and then you've got the rest 2, 3, 4, 5 going like that. that's already decent enough hand, right? We don't need to be more concrete than that. That's somebody interacting with something, like a touch surface or something like that. If you don't want to go into detail with all these individual fingers, you don't have to. You can even do it, just simple like that. Right? That's okay too, right? Maybe you want to add, a couple of knuckles here to show that, yeah, there are additional fingers here, but that works too. I often see people when they need to draw, a user touching a touch screen or something. You often have the finger coming down, and you just put the nail in like that, and it's already clear that that must be a finger, or kind of clear. It's a little sausagey finger, but it's a finger. So that's an easy way to draw these kinds of things. So don't be too afraid of drawing people, drawing hands, drawing these kinds of things. It goes beyond that. For example, what you will want to have as an interface designer is not a degree in arts, right? You don't need an art degree. What you need is a communication tool, and a communication tool that is visual. So with this, you can now express people in their most basic form, right, without embarrassing yourself. You also want to have some other communication form. You want to be able to quickly draw a document. So practice a couple times to draw, the typical folded in, document thing, right? That's one document. How do you do two of them? Well, you put another one behind that, right? So that should be something that goes very quickly for you. You should be able to draw something like, for example, an idea for something. So, even though we're all using LED bulbs now, for ideas, the bulb doesn't seem to die out. So very easy to draw, like this. Right, that's a bulb. And then you can, turn it on with some lights, turn it off with some lights. So an idea is another thing that you should know how to draw easily. So this is really more like a visual vocabulary that you should know, right? We're not going to go into more detail on how to do this here today because our time is up. But what we just did, all this drawing users, is just part of a nice little video that we have online. We had the guy who was part of the design team of the Star user interface visit us. And he showed us how he draws things. And this was Bill Verplank. And he does an excellent job at doing this. I think here's the link. Yeah. So HCI Aachen, blah, 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 /Verplank. That, if you go there, you will find a short video, or not so short video, of Bill Verplank. He came here to Aachen and showed us how to draw these things. He's amazing. If you meet with Bill, at the end of the meeting, you have like your bullet points in your notepad or in a computer, and he will have drawn like, a whole poster of graphics. It's really amazing to watch. If you want to see more examples of especially like these mildly Ku Klux Klan-like looking people here, you can take a look at Brenda Laurel's book, The Art of Human Interface Design. It's also a great early book on HCI research that is worth checking out. And if you really want to push your drawing skills beyond that, you can take a look at the Betty Edwards drawing on the right side of the brain. This author is often giving classes at Chi conferences for people who want to extend their drawing skills. But you don't need to get that far, right? You really want to mostly be able to sketch a visual vocabulary. So Bill Verplank's talk is a great starting point. Drawing on a napkin, napkin sketches is another topic. You can look for books and resources around that topic. So make yourself able to express yourself visually with this communication vocabulary. You don't have to be an artist for that. You don't need a black turtleneck. It's just a tool, right? With that, we're going to wrap up today. Have fun with Starman, and thanks for listening.
This content was provided by RWTH Aachen University.